Hello everybody, it's time for one of my favorite subjects, the phases of the moon, a absolutely core concept in understanding our night sky. And we're going to go ahead and jump right in. The date of filming is the 7th of September 2020, and the current phase of the moon is a waning gibbous. All right, so what did all that mean? How can we expect it to go from waning gibbous to third quarter to waning crescent and back to new? What is the cycle of the moon phases? That is the subject of this video. So let's go ahead and get started with the phases of the moon. This is going to be a longer video, and I am going to end it with a simulation. So if you need to stop and take a break and pause, I'll try to give you a note of when is a good time to pause, when we kind of bounce between major topic to major topic. The first thing I want to do is I want to introduce a couple of key concepts that'll help us understand the phases of the moon. You really should go to my notes and make sure that you've studied those in detail to really realize that the phases of the moon is all about the geometry of where the moon is in its orbit. So we have to consider where the sun is, where the earth is, and where the moon is, and that's going to determine our phase, or really what part of the daylit side of the moon we can see from our earthly vantage point. Well, a absolutely critical part of this is that the moon does not shine on its own. The moon is a giant rock in outer space. It's a really interesting rock and quite big. It is our moon, but it does not shine or give off any of its own visible light. So why can we see the moon in the sky? It is reflecting sunlight. So we have the sun, we have sunlight coming in, which is going to make half the moon day, half the moon night. And the phase of the moon that we see is really what portion of the daylit side we see compared to what portion of the night side we see of the moon. If we see all the day side, we see a full moon. If we see all the night side, we see a new moon. And hopefully that'll become apparent as I go through this video. But just a couple of basics about the moon itself, since we're looking at the motions of the moon, which are giving rise to our phases of the moon that go through a complete cycle every month or so. But the Earth-Moon distance. So in a lot of the times that you learn about the Earth and the moon, you always see these diagrams, but they're never to scale. So I wanted to show you a diagram of the Earth and the moon to scale. How far away is the moon? On average, it's about 384,400 kilometers. That's about 240,000 miles. And then if we go ahead and represent that here in this picture, we'd have the Earth being about this size, the moon being about this size, with the distance between. That's enough distance between the Earth and the moon to fit every other planet in our solar system between the Earth and the moon, and have just a little bit of room, about 1,000-ish kilometers or more to spare. So here is what the Earth-Moon system really looks like. The moon is actually quite far away. And to really hammer this point in, this blue line right here is the orbit of geosynchronous satellites, the ones that will orbit around exactly one time in 24 hours, so they always sit over the same point on Earth. But something a little bit more visceral to see is, where would the location of the International Space Station be? Where are our astronauts that are in orbit around the Earth? So I tried to actually put this on here, but I can't, because it's literally about 1 pixel away from the surface of the Earth on this scale. So I have an arrow that would point to basically where the orbit of the International Space Station would be, which is about 400 kilometers up. And 400 kilometers is nothing compared to 384,000 kilometers. All right, and then we'll imagine we're looking down on the North Pole of the Earth. And that means the moon would be orbiting counterclockwise. The Earth would be rotating counterclockwise if we're looking down on the North Pole of the Earth. So now we have a sense of its orbital motion as well. How long does it take the moon to complete one exact orbit, to go all the way around the Earth, 360 degrees of revolution, and come back to the same place? Well, so one complete orbit, what we call the sidereal period of the moon, takes 27.3 days, a slow process. The moon is moving around the Earth, but it takes 27.3 days for it to complete one orbit. So we could call that the sidereal period with respect to the stars, just like when we talked about the sidereal day of the moon, or we could refer to that as the orbital period of the moon. We're about to go through the phases of the moon. And if you watch in time from new moon to the next new moon, observe a full cycle of phases of the moon, you would realize that takes 29.5 days, a full 2.2 days longer. And that's because you have to account for the Earth's orbit around the sun and the moon's orbit around the Earth if you want to fully understand the phases, since it's the geometry between the sun, the Earth, and the moon. So if the Earth is moving, it's changing the geometry a little bit as well. This is very similar to the solar day and the sidereal day. I highly recommend going over the difference between the Synodic month and the sidereal month in my notes. And notice I'm calling these months because the idea of our month, about 30-ish days, really comes from a lunar calendar, because the cycle of lunar phases takes 29.5 days, just about 30 days. That's about 1 month. Just get rid of one of those two O's and you got month, and yes, those two words are related to one another. Okay, so now that we've covered the basics, we know that we have our full cycle of phases is 29.5 days, and the orbital period is 27.3 days. Let's get to actually understanding the phases of the moon. Let's take a look and see what's going to happen. We'll go outside. We're going to start observing the moon on when we can't observe it. So this is a mental exercise at this point. We'll go out and observe a new moon. The new moon is when we're seeing the complete night side of the moon, so you can't see it in the sky. It's only up during the daytime because it's right next to it's right near to the sun at this point, so we can't see it. But we know when it would happen because that's the day that we don't observe a moon. So we mark a new moon. Now let's watch the phases of the moon progress over an entire synodic month, an entire cycle of phases of the moon. This is going to take roughly 1 month, about 4 weeks to do. And what I'll do is I'm going to advance time by half a week. So about half a week after the new moon, you'll see a waxing crescent moon. Notice now we can see a little bit more of the day side of the moon. We can see this right-hand side of the moon as bright. And so we see a crescent shape as well. So we call this a waxing crescent. I'll come back to the waxing here in a moment. It just means that it's going towards full. So a full week after new, 3.5 days, a half a week after a waxing crescent, we would see a first quarter moon. Now notice that we can see half of the day side of the moon. And just like on the previous one, we see that the right-hand side is bright. From the northern hemisphere, it'd be opposite in the southern hemisphere. But the right-hand side is bright, and we're seeing more and more of the right-hand side illuminated day after day. We're seeing more of the day side of the moon every day. We've gone a quarter of the way through the cycle of phases, so we call this the first quarter moon. We're technically actually seeing a quarter of the moon lit up as well, because here we have 1/4 of the moon, here we have the night side, another quarter, and then we have the 2 quarters on the back side as well. All right, wait another half a week, and we expect more of the right-hand side to be bright, and now we see this right-hand side bright, and we have this hump right here as well. So the Latin word for hump is gibbous. So we call this one a waxing gibbous. Notice that it's close to full, but not quite full. You can't see the full disk of the moon. A full 2 weeks after the new moon, and a little bit more, you have a full moon. Now we can see the entire face of the moon, and yes, we always see the same side of the moon because it's tidally locked to the Earth, a topic for later in this semester for my 151 class. But we can see the full disk of the moon illuminated, and we have a full moon. So this part where we're going from new moon all the way to full moon, where we're seeing a little bit more of the right-hand side, if we're in the northern hemisphere, brighter and brighter night after night, we say that we are waxing towards full. So these are our waxing phases. Going from new towards full are all of our waxing phases. And if you're a fan of the Karate Kid, you can think wax on, and then we're not going to wax off, we're going to wane off. So now we've gone from new to full. We see the full disk of the moon. What we're going to do is continue on, and about half a week after the full moon, you'll notice that now the right-hand side is getting dark. We're seeing the left-hand side. We're seeing the left-hand side is the daylit side of the moon. And again, we have this hump shape, but we're going towards full, what's going to be called waning. We're waning off we're going towards new, and we're waning off towards new. So we call this hump shape a gibbous, a waning gibbous moon. Half a week after that, we have the opposite of the first quarter. We have the left-hand side is right if you're in the northern hemisphere, opposite if you're in the southern. And we call this, we've gone through 1 quarter, 2 quarters, 3 quarters of the lunar cycle. So this is our third quarter moon. And then half a week after the third quarter, we have the waxing crescent. So here you can see a crescent shape where you can see the left-hand side as bright. And then half a week after that, so a full month-ish, about 4 weeks, we've gone all the way back to new. And these phases where it's going from full back to new, where you're seeing less and less of the moon illuminated. And then if you're in the northern hemisphere, the left-hand side is illuminated. Excuse me. We see the left-hand side is illuminated. Then we say that you are waning. So you wax on to full, you wane off to new. And those are the phases of the moon. Now, can we actually understand that if we look at the orbit of the moon around the Earth and pay attention to where the sun is with respect to the Earth and the moon? So that entire thing took a full cycle of phases, a synodic period, a synodic month. That was 29.5 days. And now let's take a look at the orbital view. So the way that I've set these up is I'm going to advance time, just as I was talking through it in the previous one, at half a week intervals. But now we're going to look at the Earth, the moon, and the sun, which would be really, really far away. So I'm just going to have sunlight coming in here from the left-hand side. So it's coming in this way. So here we'll look at the orbit of the moon. And over here, we're going to have a picture of what the moon would look like for this observer if they were looking up at the moon. When I'm considering the phases of the moon, the first thing I always want to do is put the Earth and the moon in the orbit of the moon. Note which direction things are going. So I'm imagining I'm looking down on the north pole of the Earth, so I'm going to make the orbit of the moon be going counterclockwise. And then what I'm going to do is I'm going to shade in the night side of the Earth. So this side is the side of the Earth that's currently experiencing night. And I'll do the same for the moon. So I'll shade in this side over here. This is the night side of the moon. This is the day side of the moon. And now if I want to understand what this happy astronomer, what she would see from the surface of the Earth looking at this moon, I can just imagine this person looking up. And what do they see? Well, they just see the entire night side of the moon. They don't see anything. They observe a new moon. All right, so let's go ahead and wait for half a week. The moon would have gone an eighth of its orbit. So now the moon would be here. So now we have the sun over here, the Earth, and the moon. And I'm always going to put the person directly underneath. You could actually start to see that you could use this as a clock by knowing that this is noon, this is midnight. So 6 p.m., 6 a.m., and they're whirling around once per day. But now we shade in the night side. So here's the night side of the moon. And we imagine that we're this person. We're looking up. And this person could see, oh, the left-hand side is the night side. A little sliver of the right-hand side is going to be daylit. So I can see a little bit of the daylit side on the right-hand side. And if you have a 3D object, let's see if I can actually show this. I have a 3D object here. So if you pay attention to my camera, so here I have a day side and a night side of a Nerf ball. This would be the new moon. And what I'm going to do is I'm going to slightly tilt this. So you can see a little bit of the yellow side, but notice that this sphere makes it look like you have a little yellow crescent on there. I think I should have technically done it like that. So we have everything on the right side. So you see this yellow crescent. So the reason it looks like a crescent is just the fact that we're looking at a 3D spherical object from Earth. So now we have our waxing crescent. Notice that it's just really the position of where the sun is, the Earth, and then the moon. And that determines what part of the day side we can see. Half a week later, now this person is looking up, and the right-hand side, they see as half of it as the day side, and the other half is the night side. So they would see half of the moon, the right-hand side of it, being in the day, and the other half being in night. They observe a first quarter moon. Another half a week, so now we're 1.5 weeks since our new moon. This is just tracking how long since new. And we look up and we see a lot of the right-hand side as bright, and just a thin sliver of the left-hand side is the night side. And by the same way that we were playing with this before, so I can go ahead and tilt it a little bit, and now we have a dark crescent, and you can see the yellow gibbous shape of the moon. So we see ourselves a waxing gibbous moon. Full 2 weeks after the new moon, we have a full moon. This person looks up, they see the entire daylit side of the moon, and the night side is on the opposite side. Now we're waning off. We just waxed to full. So we should see the left-hand side as bright. Let's go ahead and see how that works out. So this person looks up, sees the left-hand side as bright, and sees the right-hand side as the night side. But again, we're going to have it as a crescent of night and a gibbous as the daylit side. So we have our waning gibbous moon. And notice now, yes, it is the left-hand side that is bright and the right-hand side that's dark. So as of the filming, 7 September, that's today that I'm filming right now, this is the current phase of the moon. I could extend this and I could draw my horizon and my meridian towards zenith, or really the meridian line. So I could figure out that this moon is highest in the sky if this is midnight and this is 6 a.m. at 3 a.m. So rewind that by about 6 hours. That gets us to roughly 9 p.m. Adjust for daylight savings time. Around 10 p.m. is when I would expect the waning gibbous to be rising. We're not exactly at this geometry. It's a little bit over this away instead. So right now, if you looked up, if you go outside, the waning gibbous moon is rising around 11 p.m. Just in case you want to go outside this week and check it out. Okay, so continuing on. We go another half a week from the waning gibbous, and now we're at the opposite of our first quarter, our third quarter. This person looks up, the left-hand side is the day side, the right-hand side is the night side, left side is day side, right side is night side. They can see half the illuminated face. So you see yourself a third quarter, a waning quarter. And then we have our waning crescent, and then we're back to new. So you can see that, and I'll go ahead. So these are the 8 named phases of the moon. I'll give you a little bit more detail, I'm going to show you a simulation, which will really hammer in this point. So for our new moon and our first quarter, full moon, and third quarter moons at those locations, those happen really in an instant. So that we say that they're that phase for a single day. So the new moon has a specific day, the first and third quarters have specific days that they happen, and the full moon has a specific day that it happens. The crescent phases, the waxing crescent phase, would be over several days, over an entire week, as it makes its way to first quarter. And you just see a bigger and bigger crescent day by day. Just like in the gibbous phases, they would happen over the course of the week between, the first quarter and the full moon, and you'd see a little bit more of the right-hand side, a bigger gibbous day by day. And then same for the waning gibbi and the waxing crescents. Okay, so I want to go ahead and use one of these Nebraska Astronomy Applet project simulators to actually show you something and show you a simulation of the phases of the moon, which aren't static images. And hopefully this will actually reinforce everything that I was just talking about. So I'm going to bring up the simulation. And again, I'll provide links in our README. So you should be able to see the simulation. Notice that here we have the person, we have the night side of the Earth, the day side of the Earth, we have the moon, the night side of the Earth, the day side of the Earth. Sunlight is coming in from this side. Over here, you're going to see the phase of the moon. And then this horizon diagram is showing you the moon as it rises in the east, travels in the sky, and sets in the west. And it's here, it'd be its meridian crossing time, its culmination, its highest point in the night. And I'll just go ahead and turn the simulation on and talk my way through it. So you can see as the moon is orbiting around, now this person can see a little sliver of the right-hand side as bright. And you can see this. You can see the waxing crescent. You can also visualize the Earth spinning around. So you can get an idea of the rise times and set times. Some advanced skills you can learn is using the moon as a clock. So here we go. I'm going to pause the animation and bring it back a little bit. So right here, we'll have our first quarter. Let's go ahead and pull this person down here. So here they are at 6 p.m. And they would see a first quarter moon. Keep the animation going. There's the sun, there's the moon. So yellow dot is the sun, gray dot is the moon. So you can see the relative positions. They're going to be on opposite sides of one another once it reaches full moon. Going through our waxing gibbous, waiting for our 1 day of full moon. And now we're going to have a waning gibbous. So now we can see the right side getting darker and our left-hand side is bright. So you can see this night side over here. We are waxing towards our third quarter, which will happen right about now. And as the moon is making its way in its orbit around back towards here, we are going back to new. Now notice that this entire full cycle takes 29.5 days, although the orbit itself is only 27.3 days. What the simulation isn't accounting for is that the Earth is orbiting the sun at the same time. So to get this geometry of the sun, the moon, and the Earth all in a perfect straight line, so you can see a new moon, and this geometry of getting the sun, the Earth, and then the moon all in a straight line, so you can see a full moon, that as the Earth moves around the sun, then the moon will have to move a little bit further in its orbit to get that same straight line geometry, a syzygy as we call it, which is going to be important as we move into discussing eclipses. So I know that video was a little bit long. Hopefully you now understand the phases of the moon. Go back, revisit this video as many times as you need to. Go download the simulations and play with the simulations as much as you need to get some help understanding the phases of the moon. Yes, this is a core concept. Expect phases of the moon questions on quizzes and especially on exam number 1. It'll be a major part of exam number 1. Several questions about the phases of the moon. So make sure you get this concept. I cannot emphasize that enough. If you have any questions, post them on our weekly discussion, which will be available on Canvas.